try to listen to me. Please.
Strange music with words. As your flight slowly drifts through the sky, the elves at the Mythical Information Bureau at the North Pole contact you. They would like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental energy source is based on cutting-edge technology, a set of Conway cubes contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional grid. Nice! At every integer's three-dimensional coordinates xyz, there exists a single cube, which is either active or inactive. In the initial state of the pocket dimension, almost all cubes start inactive. The only exception to this is small flat region of cubes, your puzzle input. The cubes in the region start in the specified active or inactive states. The energy source then proceeds to boot up by executing 6 cycles. Each cube only ever considers its neighbors, any of the 26 other cubes where any of their coordinates differ by at most 1. For example, given the cube at its neighbors, examples. During a cycle, all cubes simultaneously change their state according to the following rules. If a cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. If a cube is inactive but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains inactive. So, I think they choose constant as the same as 2D Conway game, but I think that's a mistake because it's 3D, so you probably want to have more bigger constants. But it will still work in one surface, right? Okay, so maybe 2 and 3 is enough because spreading through the one surface area would be the same, and it would be the same in the vertical, but diagonally it probably would be harder. I'm not sure. Interestingly, they start with a flat input, meaning that it would be rare that we will have cubes on top and the bottom. Oh, but you analyze 9 of the cubes to get to the top or the bottom, so it might be as well good. Interesting. The engineers responsible for their experimental energy source would like you to simulate the pocket dimension and determine what the configuration of cubes should be at the end of the 6-cycle boot process. For example, consider the following initial state: glider. Even though the pocket dimension is 3-dimensional, the initial state represents a small 2-dimensional slice of it. In particular, this initial state defines a 3 by 3 by 1 region of the 3-dimensional space. Simulating a few cycles from this initial state produces the following configuration, where the results of each cycle is shown layer by layer at each given z coordinate, and then the frame of the view follows the active cells in each cycle. So after one cycle we have standard glider stuff on z equals 0, but we have additional on z minus 1 and z1, and they're symmetrical, which is interesting. Yeah, so this is symmetrical, cool. At z0 here we have already not standard stuff, so states from the z-1 and z1 already modified what we would expect. But they are still symmetrical, and after 3 cycles we have also something. After the full 6 cycle boot process completes, 112 cubes are left in the active state. Starting with your given initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th cycle? Yes, that's interesting. What's also interesting is, can we actually use an infinite list to define our game? I believe we can, but let's see. Using the Haskell laziness, of course. What happened? I don't understand. Okay. It's not open, so we just delete it. Shadows in my dreams. Only shadows in my dreams. Okay. So let's define a data type for the game. So in the end we want to count all active numbers. So what we would need is, let's say game is undefined for now. So we will need a function numActive, which will take the game and tell us how many active. The problem is that we want to game contain infinite lists lazily generated, so we don't want this function to go over entire list. Somehow the fold R or something similar should be used to determine that if we know for sure that the rest of the list is nothing, we can just skip it. But question is, how would we know that? Yeah, that's really interesting. So simple answer that I see is that we can just say that the end of the list is nothing, or just end of the list. We just need a list and add to the list only in case where we increase the size of the list. So it would be sort of a list which will contain false or nothing in the end, to indicate that all consequent cells will have inactive state. How could we represent this? Of course, we can use map. And that's actually a good solution. I don't have any better solution to just use map. Because if we are considering using lists, that's really hard, because we should have three-dimensional list or something like that. We cannot use array because we don't know the entire indices. if we, for example, wanted to use lists, we should have list of lists, because for each x coordinate we need the y coordinate, and for each y we need z coordinate, and that doesn't seem to be that great. So I guess using map is the simplest solution, and what we can use is just map with default, and all default cells are inactive. So yeah, I guess nothing exceptionally excited here. Of course we can use not strict map but just lazy map, which might make sense. So what's interesting here is that how new active cells will be created, because if cell is inactive, it might be not in the map, but we cannot check all the cells not in the map. What we want to check is all cells that are nearby active cells. So we can iterate through the list of active cells and just to add their contributions to neighbor cells. And then we can go and to create active cells in the cells where we have enough active cells around, or not enough but exact number of cells. The disadvantage of this approach is that we need to actually go through all active cells to calculate even one cell. So, and if the field of space is too big, we will need to store the map as big as the number of cells, additional map.
I'm blinded by the street lights. It's like I'm hiding in plain sight, so distant on the outside. I'm a wanderer covered in disguise. I'm blinded by the street lights. It's like I'm hiding in plain sight. Distant on the outside. I'm a wanderer covered in disguise. I'm blinded.
Yeah, so we already have one map, so second map won't have any effect on the complexity, because it will just create the constant. But I think it's just nice idea to do if we can do it with no additional space, or with constant additional space. It's just better. The question is only how can we do this, right? Because we want to iterate only through active cells. So one way to do this is to say iterate through active cells, but after each active cell, so take one active cell, add all its neighbors to the separate queue, and iterate through that queue. For each inactive cell, inactive or active? Okay, so first I guess we want to know what cells will be dying. So that's easy because we just need to iterate through active cells and find their neighbors. Yeah, and we know who will die. But for finding inactive cells becoming active, you will need to end in constant in constant space. You will need to iterate through active, take one active, add all neighbor inactive cells to the separate queue, go through that queue, and for each inactive cell find out whether it will become active or not, and of course save the result, which will also take you a map, because you will need a second map to store all cells that you already checked, which is not ideal. Yeah, that's correct, that's not ideal. So, can we solve this problem at all? Because we don't have an array to iterate through, or it defeats the point. So what we don't want to do is to double count. Yes, that's the problem. We don't want when we go multiple ties through active cell to multiply add to some inactive cell. That's hard. I guess let's just create a second map because I don't see other way of not to double count. Okay, there is another way where we can just check. Also, we store the second map because we cannot update directly the current map because we are using values from the old map, so it doesn't matter, we need a second map. Okay, num active, we understand what we want. We already know that game would be a map. Map from int to what's it called, to bool, whether it's active or inactive. Okay, that's num active for you. Another would be 6. What does it called? 6 cycle. So let's cycle 6 cycles. Cycle game to the new game state. Do we need something else? Num Yeah, I don't believe we need neighbors, of course. So we want actually let's create another type. It's a type. Let's create another type which is coordinates. Chord, which is this tuple. So now we have coordinates, and we will have list of coordinates. As that's it, I believe. Oh yeah, also we want to have special. Oh, actually, when it's inactive, we can just remove it from the set. So we don't really need a map. We just need a set. Yes, because we don't care about difference between we didn't get to this cell yet, or the cell is inactive. It's the same for us. Okay, cool. Oh. Okay. What we want is read file from args, and yeah, we want to have lines, and I guess that's everything we want. For now, at least. Yeah, because we also want to have sort of width and height. So what we are doing is like say lines. And you know? Yes, indeed. Lines. We don't want to call it lines, right? Because it's not just lines. It's actually init state. Petri. Let's say it's a Petri dish, right? So yeah, because it's flat. If it wasn't flat, I wouldn't call it, but init Petri dish, just for fun. And we want to have init game, which is more than just Petri dish, which will be set from list, and since it's not array, what we can do is just we will need to run 2 iterations for x, which will be from, doesn't really matter, but from 0 to, let's say from 1. I really don't care about the indices here. To length of head of init Petri dish. And that's x. Y would be 1 to the length of init petri dish. So probably we want to swap them just to make it a bit easier. And the coordinates are x, y, 0. So from init, let's compile. Yeah, last statement in the do block. Let's actually do this, because I believe that's even simpler form. We of course can do it without links. We can just zip some lists with init petri dish elements. So we say like petri line instead of petri dish, and that would definitely work. And I'm not sure why we are not doing it right now. Yeah, and that's even better, because in case, for example, we have not equal amount of width for lines, we will still get better result. And I believe it's simpler, so I see no pros not to do this. So instead of doing such stuff, we will iterate through init petri dish. Actually, let's say petri dish, because we sort of imply that petri dish is only beginning. So what we'll do is we iterating through y, and we will zip 1 with petri dish. Yes, and here we have y and petri line, and x will be used as zip 1 to the infinity with petri line. Simple as that. It's really simple. So, and we will have x, y, and 0, because that's 0. I feel like that's amazing. Yeah, and that's easier. That's quite fun, but yeah. We sort of don't use the elements themselves. No, right, we need to use them. Completely forgot. Is active. So we need to say is active. Of course we can filter, but since we have nice list comprehensions here, I will use filter of list comprehension here. Yeah, that looks amazing. If we were trying to use map a filter, we would use map, zip, then filter by second, then map first. Yeah, this is much easier to understand. Okay, so we have init game. So what we need is 6 cycles. So what we will do, iterate cycle init game, and we will have num active on the game, and we just print it. Cycle, of course, because there is prelude cycle. Convey cycle. Yeah, let's do convey cycle. Couldn't much type game with set core, but list of games. Yeah, right, because what we'll need to have is drop. Yeah, we will need here to drop 6. Not actually drop 6, we will need to take the 6th element. Actually 7th. Or we can drop 6 and take 1, right? Drop 6 and head. That's much simpler, right? Than taking 7th element. Oh, right. Because we don't know whether it's active. So let's say celter. Cell equals hashes. Yeah, hash is active. Cool. I use more undefined actually, because you will again compile. I often get into the state where I cannot compile my program, and so I cannot use imports, but when you put undefined it just compiles. Yeah, that's more like iterative process. So num active actually quite simple. Yeah, because we have size. Yeah, because we keep only active cells. Conveys, let's start with neighbors. So our x, y, z, and we will have a list where we say x plus dx, y plus dy, z plus dz, where dx is something from -1 to 1, dy is same, and dz is the same, and we have one condition: dx is not 0, or dy is not 0, or dz is not 0. Simple. We actually can kinda can do this because it's very simple, no big deal. And it works. Amazing. So now is hardest part. So we'll need just to generate neighbors of active cells and then count number of neighbors. So we use fold-del. Yeah, we can use fold-den on the map. Oh wait, it's set, and there is no fold on set, right? No, there is. I'm not sure why would you want fold-del, but yeah, we have fold-L. Oh, there is fold. Interesting. I'm not sure what's the difference. I don't know what's the difference. Yeah, I really don't know. Let's read the docs. Fold the elements in the set using the given right associative binary operator such as fold the elements in the set using the given left associative. Cool. Oh, so fold-del is just flip the function. Ah no, that's for example. Strict folds, a strict version of fold-del. Each application of the operator is evaluated before using the result in the next application. This function is strict in the starting value. Okay. Folders, strict folder and strict fold-del. Interesting. Legacy folds for the elements in the set using the given right associative binary operator. This function is an equivalent of fold-der and is present for compatibility only. Okay, we don't use it. Oh, we have lookup, min, lookup, max, find bin, find max. Lists, debugging, show tree. We have show tree. Wow, that's nice. Internals. I don't know why internal structure can be invalid, but reading docs is amazing. Take, drop, split, element, lookup, split, partition, span, anti-tone. Wow, that's amazing functions. Cartesian product. Amazing. Disjoint union. Disjoint. This proper stuff. Amazing function we have here. Alter F. Can delete or insert X in the C depending on whether an equal element is found in S. Oh, just by the way, do you remember that we are using sets? Here we need to use maps to count the number of elements. Or we need to sort and then group by and then isn't map sorting? I think no. Yeah, map doesn't require sort, so by default using map is better. But still, we want to use foldel, right? Why would? Because we iterating through set. Yes, just because of it. Isn't foldable the same? Yeah, I believe foldable just the same. Means type T and you have foldel. Okay, so I don't see why not. And foldable does have fold R strict, which is nice and good. Cool. So neighbors and recycle. Okay, so we also need map here. Okay, so what we are doing here is, so is set part of foldable? Set. Yes, so no need to use like self foldel, just use foldel. A, B. Let's look at the source. Like, is it defined as part of being foldable? And maybe just foldel is more efficient. Let's look at Haskell foldable. And let's instance set, no set instance, but how it is an instance then? I don't understand. Okay, what we can do is to check interpreter and defined in containers. I see. So what we need to say is containers. And you have set here, data instance, data just set, and the instance of foldable, right? Strict fold, and you have the foldel. Wait, so it's data set. So I don't particularly see where you have instance of foldable. Oh, you have. Oh, is the oh, I see. Fold L equals fold L. Doesn't matter. Why do you have two functions then? Do not import foldable or what? Doesn't matter then. Fold L and you have a function. Let us create this function. Empty. We start with empty map, and we use our game. Just fine. So we will have all neighbors, and we count the numbers, and depending on the number of neighbors, on the number we of the number of cells we found, it will be active or inactive. So it's not just game, it's for fmap, right? Because set is also part of functor, right? But we don't want to return a set. Or do we? Oh, by the way, What? Set is not part of functor. Set is not a functor. In what universe? Set is not a functor. What? Ah, right, because set is... You cannot change a set. Yeah. Fair, totally fair. Do you have set map? Maybe? Yes, there is map. Set A to set B. Yeah, it should be. Why it's not a functor? Set is not a functor. I don't know. But we have a map. So yeah. But still, does it make sense to use here set as a set instead of just converting to a list of elements, which would be elements, and for each element we will have a concat map which will return neighbors. And we will have concat, we will have list of neighbors, and here we want. On the left we have the element, on the right we have a map as intended, and we will use function alter, malter. Let's use undefined just to get our map so we can properly... Yeah, here, because let's say undefined. Yeah, alter. So alter takes maybe and returns maybe. So for sure we know that we want to return just. No, actually we also want to return nothing if... No, we want then to filter. We can filter also inside, but it will be filtering twice. Yeah, we can filter. No, we cannot. We cannot say like if we found at least 4, delete this, because when we find the 5th or 6th occurrence of the cell, it will again add. So we actually need to first find the count and then only filter them up. So that would mean that we want to use just in any case. So here we have malter, and malter, as you can see, has maybe to maybe k map, so it's perfect for fold R. Fold L for fold R. Okay, doesn't matter. Let's use fold R. Alter just. So the function here is just. And we want to use maybe, right? We are using maybe to have here a 0, a 1. Yeah, exactly. Because we either want to have a 1 to count 1, or we want to apply function plus 1, which will add 1 to count. And I think that's perfect, should be perfect. Oh no, 27. What's wrong? Oh right, because again, after fold R, which will return map, we will want to have something. And specifically we want to have filter, right? So filter is just a function filter. It's not a part of foldable, right? So what we actually need then is map filter. Do we have something in map? Yeah, because it didn't compile, we lost all the imports. But if we do this, we will do filter And yes, we found the filter. So what we are filtering is by the value, and if it's oh, actually we also need to have a state of previous cell. I completely forgot about that. Because if the number of neighbors is 2, it totally depends on the state of the previous. It basically saves the state if the number of neighbors is 2. So we still need to use previous game. So yeah, that's not a problem. Let's say game, and here we also will have game. What was that? So here we found. What we want to do here is still we want filter. We want to filter all instances where basically won't have only active cells, and cell is active only when either it has 3 neighbors or it has 2 neighbors and it was active before. So let's do this. So okay, so actually what I want to do is to do no, that's filter. I just need to use map game to determine to set game, determine whether this cell was active. So here I will need to save cell, but not cell, like chords. And if this chord is if chord equals 3 or chord equals 2 and by the way, what's the more have more priority, and or so or has less priority, so yeah, that makes perfect sense. We have disjunction form, I believe, disjunction of conjunctions. So if chord is 3, actually I believe this would be a better solution. We will have alive, still alive. Yeah, that's a nice one, like the song. So if we say, oh, we need to use case here. Because it's not chord, right? So our result is a map. So we'll have keys and elements. So we have not just filter. Yeah, we'll need filter with key. Do we have such function? Filter with key. Perfect. So still alive is chord and cell. No, it's not actually cell, it's num neighbors. And we say we can replace num neighbors 3 just through from the git go. And if 2, then we need to check chords. we need to check game. So we are saying we are taking lookup. No, lookup with default, right? No, member, because game is set. So member, first member, I believe. Member is a card and game. Yeah, otherwise we don't care and say false. Still alive. Filter with key. So now we got only alive cells. So now we don't care about the number of neighbors, number of times it was encountered. So that means we'll just convert map to set. How do we do this? Easy. Elements as from list, right? So this conversion from map to set doesn't sound great or reasonable, because you can just use map everywhere, not a problem. Oh, can we return the set of elements of the map? I don't think it's possible. Bum 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 bum. Elements. Yeah, that's different. Keys set. So we have keys set. Makes sense. But yeah, not the value set. But key set is actually what we need. We don't need elements. So key set is actually what we need. Amazing. Keys set. Actually, so the naming is key set. Keys set. It's not key set, it's keys set. So using plural is acceptable here. So that sounds to me like a good name. So another question is, do we use dollar and dots or do we use just dollars? So you have to yeah, so what's else about here? Question now, do we use dot notation all the time? Because we have two times. Of course we use dots when we want to specify a function as a composition without taking an argument and then passing into the function. And I use dot notation a lot, like inside this function I use dot, right? So why don't use dot everywhere? Everywhere, and that's perfect question which has definite answer. Let's use dot everywhere. We just need to move dollar sign here, and that's perfect. We are using here dots everywhere, so no worries. Yeah, amazing. Does it work? It compiles. Wow. And we have all undefined vanished. Let's give an example. Wow, that's exactly what we was expecting. So now get our input. Okay. Example in task in. Turns out my favorite example of Haskell, where we use infinite lists to construct an infinite word, is not that great. Just using maps has the same or better effect for conveys. Main task. Okay, 3. Yeah, nice. But that's easy, yeah. For some reason, your simulated results don't match what the experimental energy source engineers expected. Apparently, the pocket dimension actually has 4 spatial dimensions, not 3. That's nice. The pocket dimension contains an infinite 4-dimensional grid. At every integer 4-dimensional coordinate x, y, z, w, there exists a single cube, really, a hypercube, which is still either active or inactive. Each cube only ever considered its neighbors. Any of the 80 other cubes where any of their coordinates differ by at most 1. 80 because 3 to the power of 4 minus 1. For example, given the cube at the initial state of the pocket dimension still consists of small flat region of cubes. Furthermore, the same rules for cycle updating still apply. During each cycle, consider the number of neighbors. For example, consider the same initial state as an example above. Even though the pocket dimension is the initial state represents a small. Okay. Simulating few cycles. Yeah, I don't need this simulation. I can understand it. It's impossible to read for the human. After 6 cycles. Okay. That's fun lore. Easy to change. Yeah, so easy to change. We just need to add another int to the core. Also, we need to change initial gain. Also, we want to change here generation of neighbors. W, and we have also dw from -1 to 1. Also adding either dw is not equal 0. What do you think? Will it work? So yeah. How would you create a space with arbitrary number of dimensions? So you probably wanted to have for some int. You can use templates, but that's not fun. So yeah, you probably want to have a list instead of tuple. And each element would represent its coordinates. And we actually can do this. And then we will have recursion for each element. But really, that's just too hard. Don't worth it at all. Yeah, let's see, like, that's all the changes we should make. Of course. And I don't even care about new line 18. One time is just fine. Star. 38. Yeah. Makes sense. 36. But chord is now for ints. So what's wrong? Oh, right here. W applies to the W. Nice. That was a lag. I'm kind of afraid to run it on task. But it took okay time, so cool. And I don't think I will go through any task anymore, so it's enough for today. Wait, I didn't get the music. Cool. About 17. Soul day 17. Make it push. Yeah, ready to tweet, which is the most important thing to do. Yeah.